Right now, something truly wild is happening in our cosmic backyard. Only 3 uninvited guests from other suns have ever been caught tearing through our solar system. The newest one, Comet 3I Atlas, isn't just here, it's putting on an absolutely unprecedented show. It's swelling in brightness, building a massive glowing coma, and frankly, confounding every prediction astronomers made. Sunlight is literally ripping at its frozen guts, and we're watching it unfold in real time. We have mere weeks, maybe even just days, before it slingshots around our star and vanishes into the interstellar void forever. What on Earth, or rather, what not on Earth, is this thing made of? Where did it come from? And why, oh why, is it puffing up faster and brighter than anyone, anywhere, ever predicted? The race is on, and the clock is ticking. Let's find out what secrets lie inside that luminous alien coma. It all started on the 1st of July 2025. The Asteroid Terrestrial Impact Last Alert System in Chile, ATLAS for short, blinked, as it always does. But this time, it found something that absolutely did not belong. The object's speed? Honestly, it was obscene. We're talking 221,000 kilometers per hour, or nearly 60 kilometers per second, and it's still accelerating. That's far too quick for the sun's gravity to ever hope of arresting it. This thing is not slowing down. Within 24 frantic hours, telescopes on 3 continents confirmed the orbit, definitively hyperbolic. Translation? This thing isn't ours. Not even close. It officially became 3I Atlas, now the 3rd interstellar object we've ever had the privilege, or perhaps the shock, of seeing. Remember Oumuamua, the first, which surprised us all in 2017? Then Borisov, just 2 years later. Both of them absolutely rewrote our textbooks. Now, just 8 years after that historic first detection, history is repeating itself. Only this time, it's louder, brighter, and frankly, far more dramatic. So why is this thing putting on such a dazzling performance? Comets are essentially dirty snowballs that throw epic tantrums when warmed up. 3I Atlas is absolutely no exception. Right now, it's closing in from Jupiter's distant realm, heading straight for the orbit of Mars. As it gets closer to our sun, that intense sunlight is vaporizing the frozen goodies hidden beneath its icy rind, carbon dioxide, carbon monoxide, and even water ice. Gas is jetting out at hundreds of meters per second, dragging along enormous amounts of dust. Then the solar wind pushes all that dust into a magnificent tail, already tens of thousands of kilometers long. The closer it gets to the sun, the wilder the tantrum, and believe me, the brighter the spectacle. Observers worldwide are reporting that its coma, that beautiful, fuzzy atmosphere surrounding the nucleus, has explosively doubled in diameter just since mid-August, now spanning several 100,000 kilometers, rivaling the diameter of Jupiter itself. On the brightness scale, it's already crept from a faint magnitude 17.5 to around 12 or 13, far brighter than any model predicted. That number might not mean much at first glance, but in practical terms, it still puts the comet well out of reach for the naked eye. Even seasoned backyard observers need at least a medium-sized telescope to spot it, and only under really dark skies. Despite these challenges, its apparent brightness has been climbing much faster than any model predicted. This explosive growth of the coma isn't just a visual spectacle, it's a key reason why telescopes are picking up so much more light than expected, boosting its measured brightness even if the solid core itself remains frustratingly hidden. But what truly makes this visitor special isn't just its staggering speed, it's its chemistry. And the first thing anyone notices about 3I Atlas, even from Earth, is its striking, almost eerie green glow. Spectral analysts immediately zeroed in on this color, scouring the comet's light for those telltale chemical fingerprints. The consensus points squarely to diatomic carbon, or C2, as the main culprit. When intense sunlight slams into carbon-rich molecules, they emit that vivid green light, especially in what we call the swan bands. This is a classic signature for active comets, but 3I Atlas stands out for the sheer intensity of its green hue. Beyond the green glow, the James Webb Space Telescope measured its coma in infrared and found something even more fascinating: carbon dioxide absolutely dominating the outgassing, far, far more than water vapor. Our solar system comets usually flip that ratio. The Very Large Telescope added to the mystery, detecting cyanide gas and traces of nickel vapor, which are common around our local comets, implying some universal recipes for planetary leftovers. Yet that CO2 excess, that startling imbalance, strongly hints that 3I Atlas formed incredibly far from its parent star, way beyond what we call the snow line, where carbon dioxide stays solid. That single clue, that chemical fingerprint, tells astronomers the comet's birthplace likely resembled the distant Kuiper belt of our own system, only orbiting a completely different sun. Every extra photon collected, every spectral line analyzed, is another line in a cosmic recipe written in another part of the galaxy. It's chemistry screaming its origin story. So where did this interstellar traveler truly begin its journey? This is where the detective work gets really exciting. Using the incredible latest Gaia star map data, researchers meticulously backtracked 3I Atlas's path, tracing its trajectory through the vast expanse of the Milky Way. And what they found is mind-boggling. Its trajectory slices right through what we call the thick disk, an ancient, sparsely populated region of our galaxy where stars are significantly older and, interestingly, richer in heavy elements. If that origin holds true, it means this comet's parent star, its home star, likely lived and died long, long before our own Earth even existed. A dying star, perhaps, or some intense gravitational pinball game played out in that ancient stellar neighborhood, could have flung 3I Atlas our way at that blistering, almost impossible speed. We will never, ever see that parent star. The comet has been drifting through the cosmic ocean for far too long. Yet its icy hide, its very composition, carries a pristine snapshot of whatever planets, asteroids, and unique chemistry once circled it. Think of it truly as a time capsule, a relic older than our sun, hand-delivered across unimaginable light years, arriving just in time for our telescopes to decode its ancient message. So how close will this incredible visitor actually come? Perihelion, its closest approach to our sun, is set for October 30th, 2025. At that point, it'll be about 1.4 astronomical units away, just inside Mars's orbit. For all of us on Earth, let's be clear, we stay safely hundreds of millions of kilometers away, so please wipe those doomsday headlines from your mind. This is a scientific spectacle, not a threat. After that dramatic swing by, the comet will climb away, never to return, on a path tilted a steep 42 degrees to the plane of our planets. But here's the kicker. By early October, the window for observing 3I Atlas from Earth is closing fast. Each evening, the comet dips lower into the twilight, pressed ever closer to the sun's blinding glare. The angle between 3I Atlas and the sun, what astronomers call solar elongation, shrinks below a critical 30 degrees by October 21st. That, my friends, is the threshold where even the largest ground-based telescopes really start to struggle.
For most of the world, that practical viewing window has already narrowed to a mere sliver of time. Amateur networks are scrambling, truly scrambling, to capture the last usable images. Professional observatories bound by even stricter safety limits have already started to pull back. The urgency here isn't just about lost photographs. Once 3I Atlas passes behind the sun from Earth's perspective, there will be a complete data blackout. The geometry of the solar system itself is quite literally shutting the door, and the comet will slip out of our reach just as it approaches its most active phase. The only hope for continued monitoring will come from assets far from Earth's line of sight. a problem that now lands squarely on the shoulders of spacecraft orbiting Mars. To truly appreciate 3I Atlas, we have to compare it to its two interstellar predecessors, Oumuamua and Borisov. Oumuamua, the first one, was a total enigma. It slipped through our system without a tail, behaving more like an inert, tumbling rock. It was detected after its perihelion, meaning we were left chasing a rapidly fading smudge trying to piece together its story from echoes. Then came Borisov, which, while interstellar, looked and behaved remarkably like a typical solar system comet, just traveling interstellar express. It arrived with only months' notice, giving us a slightly better but still rushed look. But 3I Atlas? This is the hybrid, the best of both worlds, and frankly, the most exciting. It's an incredibly active comet, spitting out dust and gas for all the world to study. Yet chemically, it's profoundly unlike our local comets. This time, we have the immense luxury of watching this interstellar visitor evolve as it warms, offering us a truly rare before and after picture of its awakening. Put simply, 3I Atlas is the interstellar guest we can actually interrogate in detail while it's still talkative, still screaming its secrets to the cosmos. So, with Earth's view rapidly closing, where does the race to watch shift? Mars, for a brief glorious window, becomes the only outpost with a front-row seat to 3I Atlas. As our Earth-based telescopes go dark in the sun's glare, the focus pivots entirely to that incredible fleet of orbiters circling the red planet. Each mission brings a different crucial set of eyes. We've got Mars Express, ExoMars Trace Gas Orbiter, NASA's MAVEN, and the Mars Reconnaissance Orbiter, all tuning in. The geometry here absolutely favors Mars. On October 3rd, 3I Atlas sweeps within about 28 million kilometers of the planet, close enough for these orbiters to attempt direct observations. Instrument teams across the globe have spent weeks running simulations, updating ephemeris files, and negotiating precious observation slots. Every single team wants a piece of this encounter because every wavelength reveals a different piece of the puzzle. Radio dishes are hunting for complex organics. Ultraviolet scopes are tracking that crucial interaction between the comet's gases and the solar wind. And don't forget the amateur observers. They're feeding in vital light curve data that helps calibrate all those outburst models. The hashtag #TrackAtlas is trending on astroforums as imagers post daily brightness reports. This combined global effort turns one fleeting visitor into nothing short of a planetary-scale laboratory. It's an all-hands-on-deck scientific endeavor. So what happens next? That's the million-dollar question, isn't it? Current models, the ones that have already been defied once, predict a gentle, continued brightening. But here's the thing about comets. They are absolutely notorious for their mood swings. This isn't a predictable, scheduled event. It's a dynamic, volatile object. An unexpected outburst, a sudden dramatic shedding of material could potentially push 3I Atlas into binocular range, making it visible to a much wider audience, though most experts cautiously call that unlikely. Still, we're watching. Either way, the comet is absolutely set to break the visual magnitude 13 barrier by mid-October. After its perihelion swing by, the fading will be swift, almost brutal. Within weeks, it will slip back to 16th magnitude, then 18th, then, heartbreakingly, nothing. By spring 2026, only the largest, most powerful telescopes on Earth will be able to pick up its final faint photons. And after that, humanity will once again be left with only 3 interstellar data points. Unless, of course, a fourth visitor barges in. But given the accelerating pace of detection we've seen, few astronomers expect to wait another 8 years for the next one. The universe, it seems, is getting busier, and we're here for it. All right, so what can you do? If you own a telescope, especially one 8 inches or larger and you're under dark skies, start imaging now. Seriously, every observation counts. Post your results in the comments below. We absolutely love seeing what you capture, and we'll feature the sharpest, most incredible shots in a follow-up video. And if you want real-time updates, if you want those crucial magnitude predictions and finder charts as they drop, then you know the drill. Smash that subscribe button. And please hit that like button so the algorithm understands just how important this story is and spreads the word. Because in literally just a month, this incredible unfolding story leaves our solar system forever. And we won't get another chance like this for a long, long time. So there it is. Comet 3I Atlas. A truly cosmic telegram sent from a long-dead star system, now glowing brighter every single night as our sun literally peels it apart. It's the third interstellar object we have ever seen. And make no mistake, once it recedes into the unfathomable depths of interstellar space, the chance to study it up close, to decode its ancient secrets, is gone forever. This is our moment. So keep your optics ready, keep your eyes open, and for goodness sake, keep your curiosity set to 11, because the universe just delivered another powerful, unforgettable reminder. We absolutely live in a crowded neighborhood, and when the neighbors finally do come knocking, they rarely, ever knock twice.